Okay, we were working on simplifying number 2A in the last video. So I always get questions from students. They go, how do you know if it needs to be simplified? So let's go back up to this one, the final answer, and see. So I say to myself, does 5 to the anything, like a nice whole number, give me 3? No. This has a variable in it, so I know it can't be simplified. This has a variable in it, so I know it can't be simplified. So basically, you concentrate on the ones that have a log and then just numbers. Those are the ones that can be simplified after you've done the power rule. So I look here and I go, these two have just numbers. This one can't be simplified because of the x. So this is the two that I will be looking at to see if they can be simplified. So I say to myself, 4 to the what is 3? Well, not a nice whole number, so that can't be simplified. But 4 to the what equals 64? Oh, that can be simplified because 64 is a power of 4. 4 times 4 is 16, times 4 is 64. So 64 is 4 to the third. So remember when I had you highlight those boxes in your notes of the perfect cubes and perfect fourth powers when we were doing radicals in chapter 6? Well, it's coming back into play now. So I have to be able to go backwards and go, 64. I think that's 4 to the something. And you can mess around on your calculator. So you can see 4 to the third is 64. So now watch what I'm going to do. So this one can't be simplified. I leave it. This one can't be simplified. I leave it. But this one can be turned into log base 4, 4 to the third. So do you see why I'm doing that? Think about the properties we just covered. Isn't this the inverse property of logarithms? The base of the log and the base of the exponent are the same, so they undo each other, which means the answer is just the exponent 3. So the simplified answer for this problem is log base 4, 3 plus log base 4x minus just 3, because we learned this expression from the last page when we were doing the properties is just 3. So when the base of the log matches the base of the exponent, and this is the exponential, the answer is just the exponent. So this is the total 100% simplified form. Okay, you want to do one more together and then you guys try one, or do you want to try one right now? Take your pick. If you feel like you're ready, go ahead and shut the video off and try B. If you feel like you need another one under your belt, we'll see. All three of these are pretty much the same. So if you want to watch another one and then try it, fine. Okay, so once again, the expression or the direction said to write as a sum and difference of log. So you can see I did that. And then it says to simplify. So the first thing I notice is, oh, there's multiplication up there. Second thing I notice is that's square root of z. Remember how we said that's the same thing as z to the 1/2 when we were doing the sample problem? See how we wrote y, square root y as y to the 1/2 because of this property we learned in chapter 6. So I'm just fixing it right there, and then that'll save us a step later. So first we deal with the numerator. So multiplication of exponents tells us to keep the base and add the exponents. So a log of a product tells us to add the logs. So we have log, and don't forget your base, that's important. I would take a point off if you forgot your base, and Alex will count it wrong too. So you have to keep the base in. So log base 7 of x squared plus, because in multiplication we add, log base 7 of y. Then we have division. Think of exponents. In division, we subtract the exponents. So the log of a quotient says subtract the log. So we do minus log still base 7, and it's z to the 1/2. So then I look down here and I go, oh, look, all variables. So I know these can't be simplified, but I do have that third property we learned on the last page. So we did the product rule, we did the quotient rule, but remember the power rule? So we can't leave powers in an expanded log. So what we do is we just bring them down in front and multiply them by the log. So this would be 2 times log base 7 of x plus log base 7 of y minus 1/2 times log base 7z. And like I said, because they all have variables, I know they can't be simplified like we did up here. So that will be my answer once I finish the power rule. See, these are pretty fun and easy, huh? Students actually do really good on these on the test. After you practice, watch the videos, do your homework, you'll think, oh, these are pretty easy, and you have to know them for pretty much every math class you take from here on out. So log properties are pretty big in your book. You'll have a whole entire unit on logs in the next class. Okay, so if you didn't try that one on your own by yourself, okay? That's double wording. Go ahead and shut the video off now and see if you can do C. Okay, and then join back up when you're done. Okay, so we have multiplication again. So it's basically the same problem we had above. So we have multiplication. So I know this is going to turn into a sum of logs. I see that radical 5, so I'm going to make it 5 to the 1/2 right now, just to save myself a step later. So multiplication turns into a sum of logs. So I'm going to have log base 5 x to the 6th plus log base 5 to the 1/2. Okay, so everybody good so far? So multiplication turned into addition, log base 5 x to the 6th plus log base 5 to the 1/2. Then we have division minus log base 5 to the 17th. So I'm hoping some light bulbs are going off here. There's a lot of power rules, but before we do the power rule, look at this. Bases are the same. Look at this. Bases are the same. Didn't we learn when the bases are the same, the answer is the exponent? Now we can't do it here. The bases aren't the same, but here they are. So this answer is just going to be 1/2. Here the base of the log is the same as the base of the exponent. They undo each other. So there's the exponent. So there's two inverse properties. Now this one, I do agree, is the power rule. Because the bases aren't the same. You can't just write 6 for your answer. But here they're the same, so we're just going to write 1/2. Here they're the same, so we're just going to write 17. So this is going to turn into 6 times log base 5x. And I always have students go, do we have to write the times? No, but I'm just trying to make sure your brain understands that when you bring it down, it does get multiplied by that. So you could write 6 log base 5 of x. That's fine. But I just want you to understand that it turns into a multiplication problem when you bring it down. This, we said, is just going to be the exponent. This, we said, is just going to be the exponent. So far, so good, right? So look for the inverse properties, look for the power rule. And then I see I have like terms here. And hopefully you guys can do that in your head. If you have half of a pie, 50 cents in your bank account, and you go out and spend $17, your bank account is now going to be negative $16.50. If you can't do it in your head, or you don't like to do stuff in your head when you're on a test, You can do it in your calculator for sure too. So 1/2 minus 17, and it'll give you negative 16.5, like we said. But you should be able to do stuff like that in your head, right? So my final answer is going to be 6, and I'll just leave the times off. Log base 5 of x, and then this turns into, as the calculator said, negative 16.5, or you could do negative 16.5, either one. And that's my answer. And I know the first one can't be simplified because see how it has a variable? So it can't be simplified. So I just leave it after I do the power rule. But these two are like terms, so I had to combine those. Yay! Fun, fun, fun. So hopefully you did okay on that one. So this one's a little bit trickier. So what I would do first on this one is maybe rewrite it with all 1/5 exponents, because these are all powers of 1, right? And the index is 5, so power over index, that would make them all 1/5. So we could write this as log. Notice the log has no base, and remember how we learned in the last section that just means it's base 10. That doesn't mean we have to write it in, but just know that there's an imaginary 10 down there. So this would be 2 to the 1/5, x to the 1/5, y to the 1/5, z to the 1/5. So that's the problem written without exponents, just like we did, without radicals, turning it into an exponent, just like we did up here. So these are all 1/5, 1/5, 1/5, 1/5. So this is our new problem. 2 to the 1/5 over x to the 1/5, y to the 1/5, z to the 1/5. Okay, next, what I want you to realize is anything that was in the denominator of a fraction became negative because division is subtraction. So z was in the denominator of the fraction, notice it became negative. 64 was in the denominator of the fraction, became negative. And that's because if we bring the exponent up, it becomes positive when we're using exponentials. So it's negative down here, it's positive down here, you bring it up, it's going to turn negative. So think of like when we did this in chapter 4. This turns into x to the -2, right? Because when you move sides of the fractions, the sign changes. Well, that's why these are negative. So anything that gets brought up from the denominator, it's going to behave just like we did with our negative exponents, except it's going to be a negative log. So the reason I'm telling you that is now you have 3 different things in the denominator. So it's multiplication. So a lot of students go, oh, it's going to turn into addition. Well, yes and no, but then when you bring it up, that addition is going to turn into subtraction because they're all in the denominator. All their exponents will become negative if you bring them up. X to the -1/5, y to the -1/5, z to the -1/5. So when you go to expand the logs, you need to make sure they all have a negative in front. So moral of the story, any factor that's in the denominator of the argument of a log, and this is really a busy log, it really needs a parenthesis, is a negative when you go to write it out and expand it. So this turns into log 2 to the 1/5, and these are all in the denominator, so they all need to be written separately, but they all need a negative sign in front. So minus log x to the 1/5 minus log y to the 1/5 minus log z to the 1/5. So all of them are negative because they are all in the denominator. So now let's do the power rule. So bring all those 1/5 down in front. And notice they all have an exponent except the first one, so that's the only one that might be able to be simplified.